All right, guys, today we're going to be talking about performing operations like addition, subtraction, and multiplication on an entire function rather than just a couple of numbers. And we're also going to talk about something called a composition of functions. So we're going to start off with addition and subtraction, and for all of these examples in these exercises, we're just going to use these functions as the functions that we're working with. All right, so g of x is referring to this function, h of x referring to this function, and so on. So the first two examples, A and B, say that we're going to add two functions together or subtract two functions together. This should not be a new thing to us, but just to remind us how to do it, we'll make a note over here to ourselves. When we are adding or subtracting two functions, we're going to want to stack those functions on top of one another so that we don't make any mistakes. We're going to want to use parentheses. So here's what it's going to look like when I stack my first two functions. I have my g of x, which is negative x squared plus 2x minus 3. That's got all of its terms. It's got an x squared term, an x to the first term, and a constant. So we don't have to leave any gaps, which we will have to do for some of these other functions. And since we're adding, we'll use our plus sign. Our h of x function is 3x squared. Make sure that goes beneath the x squared terms, minus 4. And I recommend we use parentheses because when we get into subtraction, it's going to be really important to make sure that we are remembering what this sign is and that it applies to these terms down here. All right, pretty quick addition here. We've got negative x squared plus 3x squared, which is just 2x squared. And if you're having a tough time with that, just think of negative 1 plus 3. That's what's really going on here. Negative 1 plus 3. So that's 2x squared. 2x plus 0 is still just 2x. And then our final terms over here, we have negative 3 plus negative 4, which is negative 7. So that's the solution there. Pretty simple process. We just have to make sure that we're stacking the terms and grouping them with other like terms. All right, let's set up B. B is a subtraction problem, so we'll set it up similarly, but we're going to use subtraction instead. All right, so notice because k of x did not have an x squared term, we just leave that blank. And g of x doesn't have an x cubed term, so we'll leave a space there as well. So now we're going to do some subtraction. We've got x cubed minus 0, which is just x cubed. We've got 0 minus negative x squared. That's x squared, right? 0 minus negative 1 is 1. That's why that is. We have 2x minus 2x. Those are going to cancel. And then we have negative 1 minus negative 3, which is positive 2. All right, addition and subtraction, hopefully not a big new concept. It's just something you're going to have to be careful of with keeping your signs straight. Multiplication, I'm going to skip in this video, and we'll practice some of that in class. So we'll come back to C. In D, D says we're going to take k of 3, f of 3, and h of 3, and then we're going to perform these operations. A note I want you to make here is that you need to evaluate these first. Find out what k of 3 is, then find out what f of 3 is, and then find out what h of 3 is. So I'll just set it up so that you see what I mean. If I want to know what k of 3 is, remember we've been doing this every day, we just have to take 3 and plug it in for x in our k of x function. So instead of saying x cubed plus 2x minus 1, we'll say 3 cubed plus 2 times 3 minus 1. And when I evaluate that, I'm going to get 3 to the third power, which is 27, plus 6, which is 33, minus 1 is 32. When I evaluate f of 3, I'm doing 2 times 3 plus 9, or plus 3, which is 6 plus 3. And when I do h of 3, I'm doing 3 squared, which is 9, times 3, which is 27, minus 4 is 23. So now I can finish this because I can actually do k of 3 plus f of 3 minus 23. So the answer here is 18. Okay, now into compositions, because this is definitely a new thing. This is a composition of two functions right here. The way this reads is g of f of 2. I would write that. And the way that I'm going to evaluate this is the first thing I'm going to do is I'm going to evaluate h of 2. That piece comes first because I don't know what I can put into the g function until I know what h of 2 ends up being. Once I know what that is, I'll plug that number into g of x. So I'll make a note over here off to the side to illustrate what I mean by that, and we can follow these steps. So let's say we had this composition that said f of g of 3. The first piece we need to find is g of 3. So evaluate g of 3 first. When you're done with that, you'll take the result and you'll plug it into f of x. Okay, so let's go back over to our example. What we need to do first, it looks like, is we need to find h of 2. Now, h of 2, in this example, remember we're still using our h of x function from up here. H of 2 is going to be 3 times 2 squared minus 4, because we're using h of x. So I'll evaluate that. 3 times 2 squared minus 4. That's the first thing I need to figure out. Well, 2 squared is 4, so I really just have 3 times 4 minus 4. 3 times 4 is 12, minus 4 is 8. Okay, so now I have this 8. So what I've really just done is I've decided that h of 2 is really just an 8. So what I'm really dealing with now is g of 8. So I'll take that 8 and I'll plug it into g of x. And now I have to evaluate g of x when x is 8. So it looks like g of x is my function negative x squared plus 2x minus 3. So I'll do negative 8 squared minus 2 times 8 minus 3. And now I need to evaluate that function. So negative 8 squared. Now be careful here because the 8 is being squared, not the negative 8. So 8 squared is 64, and the negative has not been dealt with yet. So this is negative 64 because the negative is on the outside of the parentheses. Minus 16 minus 3. Sorry, I think I made a mistake, and that's supposed to be a plus sign. All right, so then negative 64 plus 16 minus 3 should give me negative 51, that whole sequence there. So that means that g of h of 2 is really just negative 51. That's the process there. Now all this second one this is just another notation for these types of problems. So another way to write this would be f of k of negative 1. All right, if you want to write that out, I'd encourage it. So that means that I'm going to have to do my k of negative 1 function first. All right, so k of negative 1 comes first. And now we have negative 1 cubed. So let's just write that out real quick. Negative 1 times negative 1 times negative 1. Negative 1 times negative 1 is 1. Times negative 1 is negative 1. So negative 1 cubed is negative 1. Minus 2 minus 1 gives us negative 4. And what am I going to do with that negative 4? Well, I'm going to take it and I'm going to plug it in for f, or for x in my f of x function. So I'm going to have f of negative 4, because that's what I got from my k of negative 1. All right, that's just 2 times negative 4 plus 3, which is negative 8 plus 3, which is negative 5. All right, so that means that f of k of negative 1 is negative 5. One thing I want to point out is that this is not a multiplication sign. It's a totally different symbol that means of. So this means f of k of negative 1, and this means g of h of 2. These are two different notations. Either is just as likely to be used on the Common Core exam, so we have to be sure we're familiar with both. All right, that's it, guys. We'll cover multiplication just a little bit in class, and then we'll get started with our practice. So I'll see you guys tomorrow.